Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is a word explosion, and it is a hard level problem. So for this particular problem, I'll give you a hint first that this problem can be solved with disjoint set, and if you have not solved the problem and you already know how to use disjoint set, then you are highly encouraged to solve this problem on your own first, because I believe that this problem is not very difficult. The only reason they have labeled it hard is because they feel like that disjoint set is an advanced data structure. So this is my view, and you can look at the accuracy also. It's 81%. So that means a lot of people are able to do this on their first attempt. That means that this is not a very difficult problem, right? So if you still want to watch the video, you can watch the explanation. I'll be explaining how disjoint set will work in this particular case. Now let us quickly start with the problem statement. So this particular problem says that Geek is a chemical scientist. So basically there are some mixes in the form of pairs. So actually they're not given in the form of pairs, they're given in a form of two-dimensional vectors, right? So the zeroth position will be x and the first position will be y, right? So we have been given this kind of mix. So it will be basically some integers, right? So the person can mix these integers, and there is also a danger array which says that if two elements, if somehow they are mixed together, it will lead to an explosion. So let me just show you the example. It is much better to show you the example, then it will be clear to you. So the question says that n is equals to 5 and m is equals to 2. So n is equals to 5 means there are n elements, and there are there will be a series of n mixes, and there is m is equals to 2. That means there are two cases in which an explosion can occur. So danger, if you see the danger vector, 1 and 3 are together, 1 and 3 are together, and 4 and 2 are together. That means if somehow elements 1 and 3 get together, they will cause an explosion, and if somehow elements 4 and 2 get together, they will cause an explosion, right? So now what happens is the scientist mixes 1 and 2 first. So no problem, 1 and 2 are compatible. Now the scientist mixes 2 and 3. So first of all, let me just also show you the answer vector. So if the scientist was able to mix 1 and 2, so the answer would be yes, right? And very important in this particular question, you only have to go in the series in which, or in the order in which the mixes are performed. So the order should not change. So first of all, we have mixed 1 and 2, no problem. So we have printed yes. Now 2 and 3 should be mixed together. But if you see, 1 and 2 are already mixed. That means 1 and 2 are together. If I mix 2 and 3, then it will cause an explosion, because 1 and 2 is together. So if I mix both of 1, 2 and 3, then 1 and 3 will be together. So it's more like, for example, if 1 was here in this flask and 2 was here in this flask, now mixing 1 and 2 means that you mix both of them, and like for example, you have first put 2 here and then 1 here. It's something like this. So this will also have a mixture of 1 plus 2. This will also have a mixture of 1 plus 2, right? Now if you have 3, now if you put it here, right, so it will have 1 plus 2 plus 3. So eventually 1 and 3 will be together, and this will cause an explosion. So this is what we have to avoid, right? So once we have found this, we know that the that 1 and 3 cannot be mixed together. So the second answer would be no, right? So 1 and 2 are still together, but since we did not mix 3, so there will be no change in the mixtures. It's just that we have to print the answer no. Now 4 and 5 are mixed together. So can 4 and 5 be mixed? Yes, there is no problem. So the answer is yes. Can 3 and 5 be mixed together? Yes, 3 and 5 can be mixed together, and it will make it 3, 4 and 5. Right. Now 2 and 4 can be mixed together. The answer is no, because 2 and 4 can not be mixed together because they are directly present in this particular danger array, right? So we don't even have to check the mixtures. We can just check that 2 and 4 cannot be present together, as this will cause an explosion. So this is how it works. Now the only thing that we need to take care, apart from these direct mixes, for example, like we at the last step, in this case the answer is no. At the last step, 2 and 4 were supposed to be mixed together, and 2 and 4 were directly present in the danger array, right? These are some cases which we can directly figure out, but there are some indirect cases as well, as we have seen in the case of 2 and 3. For example, 1 and 2 are mixed together, then 2 and let us take the danger array to be 4 and 5. Like the danger array is this. So let us consider this for a moment. Now 1 and 2 are mixed together, 2 and 3 are mixed together, and 3 and 4 are mixed together. And now I want to mix 5 with 2 or 5 with 3. 5 with 4 we cannot do. So it is visible to us directly that 5 and 4 we cannot do. But even if I want to do 5 and 3, 5 and 2 and 5 and 1, we will not be able to do it because eventually it will get back to 4, right? Because these are all in the same mixture, right? So this is what we have to found using the disjoint set. Now what actually disjoint set helps us to do is, so disjoint set is actually a form of a tree data structure. So for example, if let us take the same example 1, 2, 3, 4 and 5, right? We will be adding them one by one. So what we do is, first of all, 1 is there in the mixture, right? So what I do, if I want to add 2 to it, I'll do it like this. I'll add 2 to it like this. So this is the graphical representation of what is actually happening in the disjoint set, right? So if I want to add 3 to it, I'll add 3 to it. If I want to add 4 to it, I'll add 4 to it, right? Now there will be a function called find a particular node x, right? So if I do find of 2, it will return me the root node, so it will return me 1, right? If I do find of 3, it will return me the root node, it will return me 1. If I do find of 4, it will return me 1. So it will always return the root node, right? Now what is the advantage of this particular approach? Now whenever I want to find whether 4 and 5 can be mixed together, first I want to find the root node of this and this, in which tree it is present. So 4 for 4 it will return 1, right? And for 5, since 5 is alone right now, it will return 5. So we will eventually have 1 and 5, that 1 and 5 cannot be mixed together. Now if I find the root for 2, it will be 1. For 3 it will be 1, for 4 it will be 1, and for 1 it is already 1, right? So 1 and 5 cannot be mixed together, that means 5 cannot be mixed with either of these, right? So this is how actually the disjoint set works. Let me give you some more examples. So the basic idea is that if we have some element x and we have another element x, if we want to make them together, right, we make them connected to the tree and assign them a parent, right? So its parent is like its identity. So for all the nodes in a particular tree, we have a common identity that will be equal to its parent, or the root node actually. So the root node will be the identity of each and every node in a particular tree. So how will it help us? If all the nodes in a particular tree have a common identity, right? So it will help us in determining the identity of this one and the identity of this one, right? And in one stroke we can find that 5 is not compatible with any of these, because all of these have the same identity. So for example, in this case 2 and 4 were lying very different apart, right? But actually they are part of the same node, and even if I mix 5 with 2, then it is also a problem. So that is why I assign a common identity to 2 and 4 to depict that they are both actually the part of the same tree, or in this particular case they are both actually a part of the same mixture, right? This is what disjoint set is very helpful in, to determine all the elements that are part of the same tree, or in this case all the elements that are part of the same mixture, right? So this is how we'll be using disjoint set to determine what all are the elements that are present in the same mixture, and how we can avoid the explosion, right? So this problem has a very small constraint. So n is up to 10 to the power 3 and m is up to 10 to the power 3. So what we basically have to do is you just have to loop through all of those values in a n square fashion. So outer loop will be n and the inner loop will be m. So first of all, when we add these two, we just check for every of those whether it will cause a danger or not. Otherwise, if it causes a danger, I print no. Otherwise, I print yes and merge them, right? So I'll just give you a brief walkthrough of this particular test case only. So let me just clear up some space here. So initially 1 and 2 were not, so initially every element, let me just write it one by one. So 1 and 2 is not causing any problem, so I just mix 1 and 2. So 1 and 2 will be a part of this tree like this. 2 and 3 will cause problem because 2 is part of 1 and 1 and 3 is in danger. So if I ask the identity of 2, it is 1. If I ask the identity of 1, it is 1. Right. Now I want to mix 1 and 3. So first of all, I'll ask their identity. So identity of 1 is 1 and identity of 3 is currently 3 because it is not part of any tree. Right. So now 1 and 3 cannot be mixed together, it means. But if I ask the identity of, but here I want to mix 2 and 3, and if I ask the identity of 2, it is also 1. So 1 and 3 cannot be mixed together. That means 3 cannot be mixed with 2 as well because its identity is 1 only. So that is why we move forward. Now 4 and 5 can be mixed together. Yes, 4 and 5 can be mixed together. So let us assume that 4 is the identity, 4 is the root node and it is the identity of 5. Right. Now can 3 and 5 be mixed together? Yes, 3 and 5 can be mixed together. How will we mix it? Now since 4 and 5 are together, now even if I like do this, the identity of 3 would still remain 4 because the identity of 5 is also 4 and the root node is this one. So the identity of all the elements in this tree would be equal to the root node. Now if I want to mix 2 and 4, so 2 and 4 is already in the danger list, so we cannot mix it directly. However, how our algorithm will find it is like, first of all, it will find the identity of 2, right? So identity of 2 is 1, identity of 4 is 4, right? So this is from the mix array. So here we have found the identity to be 1 comma 4. So their identity is 1 comma 4. Now in the danger array, their identity is 4 comma 1, right? So you can swap these elements to be in sorted order. So 1 comma 4, 1 comma 4, this is same, so this is not valid, so we cannot mix these two elements. So let me just show you the code. I'll explain along with the code, and it will be much better if you are able to understand from the code. So in the answer vector, what I've done is I've initialized my string answer. Now for every disjoint set, so disjoint set here we will be maintaining by an array. Now if you want to learn disjoint set specifically, you can watch Code and Code's playlist on disjoint set. It is a very beautiful playlist. It only has 8 videos, and if you watch all of them, you will be able to do any problem of disjoint set. Right? They're very simple to understand and very straightforward. So now what you can do is I just run a loop and I just find the parent of each of them. So disjoint set is maintained by so here I'm using a technique called path compression by finding disjoint set. This is also, you will find it in Code and Code's playlist. So if disjoint set of x is less than 0, what I just do is it returns x. So what happens is whenever an element is the root of itself, right? So if an element's root is the element itself, it will be having the negative values, where the negative value will denote that it is a parent element, and the value, the absolute value of the negative value will be denoting the size of the tree or the number of its children, right? So this is the importance of the negative value and the absolute value of the negative value, right? So if it is negative, that means the node itself is a parent. I just return x. Otherwise, I'm returning disjoint set of x is equals to find out disjoint set of x. So this is basically a technique called path compression. It is very easy. It might look like some magic is going on here, but this technique is very easy. You will find it in that playlist. Now, what we just do is, if a is greater than b, I just swap them. So this part is only because I want to make them in sorted order. Like in this particular example, you saw that 2 and 4 and 4 and 2. These were in opposite orders. So if you try to match them, they might not match. So it's better to just have them both in one particular fashion. Either you can have both of them like 4 and 2, or you can have both of them like 2 and 4. Right? So it's your choice. So I wanted the smaller element to be first. So this is why I've swapped them. Now I just form an OK variable. OK means that it's just a flag. If this flag is true by the end of this for loop, then it means these two mixtures can be mixed. Now again, for the x and y also, I just find them. I just try to find that the parent element or the root node of the tree they are currently in. Again, the simple swap. Now if a is equals to x and b is equals to y, that means those two elements exactly match. That means these elements cannot be mixed, and so this will be equal to false, and then we can just break out. Now if this is true, then we can mix it. So we mix the two elements a and b. So if you see the merge function, now if a is equals to b, that means they already have the same parent. That means they already are in the same mixture. That then we don't have to do anything. We just return. Otherwise, what we do is this technique where I'm swapping these two elements is called union by rank. In this particular technique, what happens is, for example, if you have two different trees, right? Now if you just randomly merge any tree into any tree, this might cause some problem. And also if you merge a bigger tree with more number of nodes into a smaller tree, that means you have to change the parent of that many elements. So let me just show you a quick example. So for example, this tree has these nodes 3, and this tree is pretty big, right? This tree is very big, right, like this. So I've already told you the ID of every node in a tree in desired set is equals to its parent, right? Now here also the ID of every node is equals to its parent. Now if I merge this tree into this tree, that means I'll have to change the ID of all the elements to this particular node or the root node. But if I change this, if I merge this tree into this tree, then I'll have to change the ID of these 3 elements to this particular root node, right? So it is always optimal to merge the smaller tree into the bigger tree. That is why we are using this, we are swapping these 2 characters to find out the bigger tree, and this technique is called union by rank. This is also you will find in those 8 videos. I highly encourage you to watch that particular playlist. It's very simple and very easy. So here I'm just doing that merging part, where I just merge B into A and I set the parent of B as A, right? So this is all the merging part, and at the end I can just return answer. So if you had some problem understanding in these 2 functions, I believe you would have easily understood this part, because this is just like semantics kind of thing that you want to merge, that you want to find. So this find function will find the root node, this merge function will merge 2 root nodes, right? This is the clear part. But you have some problem, if you have some problem in understanding these 2 functions, you can watch Code and Code's playlist. It is very easy, and like I'm not doing any kind of promotion, but that playlist is actually very good. So at the end you can just return the answer. So this would be the solution for today's problem, avoid explosion. And I hope that you guys were able to understand the solution. If you guys did, then you can show your appreciation by dropping a like on this video, and don't forget to subscribe to this channel, as it helps the channel grow. And if you are able to derive some value from this video, then definitely you should subscribe. It's always free of cost, and if you don't like the content later, you can always unsubscribe. So till the next video drops, keep coding, stay safe, bye bye.